So today we're going to talk about the 5895 XL power supply. For a Fahrenheit part number, this would be the RPS 1000. There's not really any notable differences between the two. This one in front of you is the Silent Night. I want to go over this as a a broader view right now where you can see the whole thing. And then I'm going to zoom into the terminals a little bit as we start talking about the actual wiring. So first I want to start with some notes like I did last time we had a panel in front of us. One, as you can see, I obviously did not use conduit in this install. On our job sites, we need to make sure we're going to use conduit and bushings and all the required things like that. This is just for a temporary training purpose. So again, we're going to use our imagination and pretend that there's conduit there. Also, you may notice I do not have a service loop inside this panel. That's because my personal preference is to have the service loop in the ceiling above the panel before the wire comes down the conduit. It keeps the overall install nice and neat. However, if you do want to have that, you want to have your service loop in the panel, not above the ceiling, that's fine as far as I care. It's personal preference. As long as you have the service loop, my recommendation would be to put it over on this side here so that it stays out of the way of your terminals. A couple other things up here in the top corner. This is where your 120 volt would land from your electricians or your building power. Right in here, this is where your dip switch for your address is going to be. Then down here on the terminals, we'll get more into those. There's a diagnostics LED labeled right here. It's basically a yes or no test. Yes, it's polling, it's working okay. No, it's not polling, it's not communicating to the panel. So now I'm going to take a second. I'm going to adjust this closer in. Oh, before I adjust it closer in, actually, this card down here is not part of the 5895. This is a 6815 SLC loop. I wanted to show that it mounts in the mounting poles that come in this panel. This can be a really helpful thing to come on job sites. There's just the 4 screws in the corners. And over here on this side, there's 4 more. So you could actually mount 2 of these in this cabinet. Being able to remote mount these like this on a job site can save you a lot of time and wire. If, say, you're working at a school that has 2 or 3 SLC loops, one of those will obviously have to run back to the fire alarm control panel because one SLC loop that we will always use is on the motherboard of that control panel. The one I recommend doing, and I try to lay out all the schools to do it, is whatever smoke detector is directly above the panel will be the loop that lands on that motherboard. And then any other loops we add on a Silent Night or Fahrenheit system, they use these cards, and we can install them in any of these power supplies. Again, the RPS 1000s or the 5895s, they can all house them. So if you go to the part of the school that loop is already ran in and you use one of the power supplies in that area or the closest power supply to that area, that's going to minimize your home run and make your install a lot easier. And it'll also keep your fire alarm control panel clean, because as you can see, we have the spare area in this panel to install this, and it stays clean and neat looking. Sometimes the fire alarm control panel itself can get kind of full. So if we start stacking all these cards in there, it adds that many more wires and that many more connections to be made. So it gets a little messy. So that being said, that's this card right here. Right here behind these 4 wires, there's a dip switch address bar. It's probably hard to see on this camera. You might see a little better when I move this camera in a second. That's where you set the address on this. It uses the same binary addressing that this uses. You're not going to be able to see it in this video, but I set the dip switches on this one to be address 1 and this one to be address 2. So here's that address block right here, those dip switches. I'll move this wire out of the way. This is what dip switches look like if you've never seen them. It's just a little black box with little switches inside of it. And up here, it was defaulted with 1 up and all the rest down. That would be address 1. I made it address 2, so I pulled 1 down and pushed 2 up. So all these come with address 1 pre-selected. So if you don't change the address, when it checks in on the SLC loop, it'll check in as address 1. All right, then this wire right here, this is my S-bus out. That's just coming, just coming to these terminals here. It's kind of off the screen, so I'm going to pull it up so you can see. It's just this wire, and it connects right here to my S-bus out. So I'm going to talk about S-bus for a second. And I'm going to start with the main S-bus in and out over here. And you see we have negative, positive, A, and B. So I talked last week about S-bus, the negative and positive. That's our 24-volt power for the 4-wire bus circuit. And then A and B is our data communications. So that's something between 2 and 5 volts. And I said I always use the same wiring scheme no matter what job site I'm on, where I'm at, I always wire S-bus with the same color conductors in the same places. And so that's going to be, I use my black wire as my negative for my 24 volt, and my red wire is my positive. So you can see that here. And then I said I either use yellow or white, depending on what conductor color comes in the 4-pair, as my A, and my green is my B. So you can see I did that here. Now your main S-bus in and out, this is the side that comes from the fire alarm control panel. And if you want, you can just land your S-bus wire on here and go to your next panel and your next panel and completely ignore these over here if you're confused by them. And it should work that way unless you either have too many panels stacked on the circuit, or your wire run gets too long and it starts pulling the circuit down. That's where these other two come in to help. Now, anytime we're looking at something that says in and out, whether it's SLC in and out, S-bus in and out, whatever else, you think of it from the perspective of the panel. So the origin point of whatever the signal is, whatever the circuit, whatever the power is, it starts inside the panel, and then it has to go out to the field. So S-bus out is where we would go out to another power supply. In this case, we're coming out to this loop card. It would be where you go to amplifiers. And what's happening from here to these S-bus terminals, from your main over to these, is there's a repeater in there, something that's receiving the signal from the fire alarm control panel, and it's re-strengthening it, refreshing it, giving it more power, some more data communication headroom. And so it repeats the signal so that this is like a whole new S-bus circuit, but it still communicates with the original one. So anytime I'm wiring these up, no matter what job I'm on, where I'm at, I like to come in with my S-bus that comes in from the field, and I land on my main S-bus in and out because that's the way it's supposed to land. But when I go back out to the field, if I have one of these power supplies, I always use this out just in case, and I never have any communication problems that way. So I hope showing it like this with this wire coming out of my S-bus out to hit this SLC shows you that, okay, from my fire alarm control panel comes in here, and then out to the field goes there. I hope that makes that simple enough. That's kind of as easy as it is to mess with S-bus. You just, again, you land your 4 wires in the same 4 places. You never cross A and B. Older data circuits on some different panels, sometimes it would have to be A and B on panel 1, but whenever you got to panel 2, you had to reverse them, but then panel 3, you reversed them again, and tracing that out could get kind of confusing. S-bus isn't that way. A always goes to A, and B always goes to B. So over here, we have our 6 input outputs. They're called that instead of NAC circuits, because on this panel, it's actually intelligent enough that these can act as conventional zone inputs or as NAC outputs, 24 volt outputs. They can actually work for releasing services as well. We don't really do any releasing systems, but it is UL listed for that. And you'll notice the terminals are labeled O and X, not negative and positive, because if you're using these circuits as inputs, your negative and positive actually flips. So right now I have them all landed where you have the red is on X and the black is on O. So it's O, X, so on and so forth, because all of these I'm wiring up like NAC circuits. And by the way, I'm not doing the meter demonstration on the NAC circuits because I did that in our last video, and I don't want to waste your guys' time more than I have to. In this instance, this is what it would look like if you're wiring either all auxiliary power or all NAC circuits or any combination of. Your negative conductor is going to be on your left-hand side of the circuit, and your positive will be on the right-hand side for that O, then X. If you were using it as like a conventional zone input, say you have some heat detectors in a parking garage and you want to pick them up with this instead of going and putting mini modules all over the place, they would land the other way around. So your red wire would land under O and your black wire would land under X. So they call these flex puts. If you're ever reading the manual and having to look that up, they're not, it doesn't refer to them as inputs or outputs or NAC circuits or anything like that. They call them flex puts because their use is flexible. So all of this configuration of what each circuit does, because you can mix and match, you can have 1 or 2 of them being inputs and then the rest being outputs. You can use any combination of them to be auxiliary power or door holders versus NAC circuits. But all of that is handled through the programming of the fire alarm control panel, then communicated over this S-bus wire to tell the panel what to do with that information. if you have something like a conventional duct detector put up, that duct detector requires 24 volts and it requires some kind of contact monitoring. It can be with a monitor module, or we could use one of these conventional zone inputs. Now, if that duct detector, I'm sorry, not duct detector, beam detector is what I'm trying to talk about here. If I've said duct detector up to this point, I apologize. If we have that conventional beam detector that requires the 24 volts and the contact input, that 24 volts will need to be resettable, because if that beam detector ever goes into alarm, the only way to reset the conventional beam detector is you take the power away from it and then you turn it back on. And the most efficient way to do that is with what's called resettable auxiliary power. So if you have non-resettable auxiliary power, it's just straight 24 volts all the time, never changes. You can, I mean, unless the panel turns off. But if the panel's in alarm, it's still 24 volts, supervisory, trouble, standby condition, everything. It's 24 volts. Resettable 24 volts is all the exact same things, except when you hit the reset button, it turns off for a moment and then turns back on, so that whatever's on that circuit will power cycle with it. So we use that with conventional 4-wire devices, such as those conventional beam detectors. I suppose conventional duct detectors could work that same way as well. So maybe that wasn't the worst thing to misspeak about. If you have old conventional 4-wire smoke detectors, they will also use the auxiliary resettable power, because the smoke detector will go in alarm, and when you hit the reset button on the fire alarm control panel, there's no intelligent communication to a conventional smoke detector, nothing telling it to reset. So you have to pull power away from it and then reinitialize the power, and that smoke detector turns back on. And as long as the chamber is clear, it won't return back to alarm. Now, if you do have to use one of these to do a 4-wire conventional zone, it pairs them so that terminals or circuits 1 and 2 will work together. 1 will be your conventional zone circuit, 2 will be programmed as your resettable power. And that's whenever you're in the programming, there's a selection for 4-wire detector, and it will automatically group these two together. And if you're using a 4-wire detector, you don't have a choice on that. 2 will become power, 1 will become your zone, unless you tell it 3 is your zone, because then 3 and 4 get paired, or 5 and 6 get paired. But it's the same thing. Your odd numbers are always your they're always your zone, and your even numbers are always your power. You're probably going to forget that before that ever comes up, just because that's not something we do every day. But these videos are on YouTube, so if you ever need to come back, that'll be there for that. Trying to think what else. Oh, you can use it for 2-wire detectors. Most conventional systems we put in use two-wire detectors, not 4 these days, unless it is something like a duct detector or beam detector. So these can also, all 6, be set up as individual 2-wire zones, and none of them function as auxiliary power. Again, that's all handled through programming. The only other thing I want to talk about while I'm talking about the 5895 and the RPS 1000, I also want to bring up the 5496 NAC panel. That one works all the same as this, except it's smaller. So it has the main S-bus in and out, but it does not have a repeater. So you won't have these 2 terminals here for your S-bus in, your S-bus out repeater. It doesn't have that. The cabinet is smaller. It will not have a place to mount your SLC card. And it only comes with 4 of these circuits, not 6. Oh, and these relays right here, relay 1 and relay 2, those are completely programmable. They can do whatever you need them to do. So if you need to give a general alarm signal for door locks or sound shut off or whatever, these relays are available for that if you have this panel close by. They can be independently programmed. So relay 1 does this function, relay 2 does that other function, or they could be grouped together in programming and you have 2 relays doing the same function to control 2 separate things or whatever. But that is something, again, that the 5895 has, the RPS 1000 has, and the 5496 does not have. Other than that, there's not a lot of differences of the 5496 to these other 2 panels, so I'm not going to do a separate video on those. Because if you can understand and trim out this panel, the other panel is simpler. I believe that is all that I have on this subject. If anyone has any questions or something I didn't explain correctly or anything, now would be a great time for that. And I'll stay here for a few minutes to be open for questions. And then, as always, if y'all don't have any questions, y'all are free to go. Thank you for being here. Thank you for your time. I'm glad we can do these and keep working together so that we can all get better and better every day.